computer. So let's talk about classes again. What are classes? Someone tell me what a class is.
The blueprints from which you could build objects from.
Exactly. So a blueprint in which you can build objects from. And what is an object in Python?
Everything.
Everything's an object in Python. Exactly. So I think yesterday we used like a dog class to create dog instances. So like you can have multiple dogs. So like there's this class is a blueprint to creating a dog and their instance of a dog. So I have a dog, it's Chocolate Lab. His name's Drakey. He is an instance of a dog. So there, and he has unique attributes. That instance of our dog has unique attributes such as the coat, his name. For here, I think we did like number of legs, which might be unique per dog, but it also can be like every dog generally has 4 legs. So it might not be unique for each individual dog. Anyway, all right. So again, we can also think of objects as nouns, person, places, or things. So when you think of a class as an object, think of like a noun when you're trying to describe an object. Each object, has attributes to them, and you can create instances of those objects. What questions do you have right off the bat? Where like, what's a little bit confusing right now when it comes to classes or objects? Or is it still kind of, is anybody specifically having like a difficult time trying to comprehend what an object is?
I'm definitely having a little bit of issues wrapping my head around it, but the more I do it, I kind of understand what each piece is doing. So I think for me, it's just a lot more practice of actually building out classes.
Yep. Awesome. Yeah. So this is like object-oriented programming. It could take a while to actually just like kind of sink in and fully understand, especially if all we've been doing is like functional programming. Like, what's the point of object-oriented programming? But yeah, so and again, we're just going to keep on building classes, talking about OOP and objects and all of that. All right, so let's continue to talk about classes. So let's create a new class. So right here we have a dog class, but let's just build something pretty straightforward, a person class. So again, we can build people, places, or things. You can build dogs. You can build, I don't know, cups or glasses, headphones. Anything could be a class. Just any object can be a class. A tree class, a leaf class. But let's. So I'm gonna list everything out. I'm gonna create a new file called person.py. I'm gonna person.py. So I've got this person file open, and I'm gonna create a person class. So we're all people in here. So how many? There's 23 person instances in this Zoom room now. So there's 23 people or person objects in this Zoom room right now. And each person in here has their unique attributes about themselves, their name, age, gender, like number of eyes, legs, fingers, occupation, if you're working right now. And we all also have behaviors, things we can do. Like we all can sleep, we all can eat. We can all say hello, we can all say goodbye. So these are all unique attributes. Some of us have like specific talents, like can juggle, or I don't know, weird ass talents y'all have, but but everyone is kind of unique. So if I wanted to create a person class, so I'm a class person, like so. I'm going to do pass right here. And I'm going to create a couple of people, I guess. I'm just looking at people on here. We have Tressa. So I'm going to create Tressa. What else? We got William. What else we have? And we have Sophia. Oh. So I've just created 3 instances of people or persons that are in this class right now. I've got Tressa, Will, and Sophia. Any questions about what an instance of a person is? Oh. All right. So again, to create a class or the blueprint, we use the keyword class.
Tom, good question.
Yep.
So is it safe to assume that in this instance you have the person class, and then down at the bottom we've got all 3 persons objects that we're creating from the person class? So
Correct.
In this case, they're all objects.
Correct. Yep. So if I wanted to see, if I wanted to print Tressa and run this code, Python person. So Tressa is a person object. And I can do the same thing with William and Sophia. And they're all different instances of the person class. So they might all look the same, the person objects, but they're all unique instances of a person, just like everyone in here is a unique person. So right here, I'm creating a new instance by doing person with the parentheses, but I'm not actually passing in anything about this person. So if I wanted to have each person is unique, each person has specific attributes about themselves. When I create a new instance, so when you're born, you're generally given a first name, last name, date of birth, gender specifically. So if we initialize or instantiate, that's another term, like instantiate is creating a new instance of an object. So def dunder init, this double under is called dunder. So this is a built-in dunder method that comes already included in a object. I need to pass in the self keyword as the very first argument in all these methods. And if I wanted to have like name, age, occupation, yeah, I guess that's good for right now. So I can say self dot name equals name, self dot age, and occupation. All right, so I'm just going to comment out William and Sophia. And so if I wanted to create an instance of Tressa, I'm going to have her name Tressa. I'll just do first names. Age, I'm just going to say, 2020, and occupation, software engineer. So now, Tressa has some attributes, her name, age, and software engineer for occupation. And these self.name, self.age, self.occupation, These are called instance variables because they are unique to each instance of the person object. So if I did William, he would have, a different name, age, and possibly occupation. So these are the self.name, self.some variable. Again, those are called instance variables because they're unique to each instance of the object. I can see what Tressa's name is by doing Tressa.name to access each instance variable. Like right there, it says Tressa. And also, I can see what methods come pre-built within each class, as well as what attributes I have access to in this person class. Does everyone remember how yesterday I went I did dir followed by whatever class name there is? So if I did dir Tressa, again, Tressa is an instance of a person object. And if I print that out, I can see all these built-in Dunder methods that come with the person class. And these are all, pretty much all these are universal to all classes, except when I come down here at the very end, notice how I have age, name, and occupation. Those are attributes or variables that belong to the person object. All right. Again, you have to, for the Dunder init, this is the initializer method. This is automatically invoked when I create an instance of a class. And I must pass in these arguments in the order that they show up in the init method. All right. Any questions about instance variables like these? No. All right. So I can create instance variables, but I can also create instance methods. So def, I'm going to say like eat, self. So again, instance methods, I always have to pass in the self keyword as the very first argument. So return nom nom nom. So this person can eat now. So they have a specific attribute. They have the ability to eat. And I can invoke that by doing Tressa or whatever this person object is called. It's a variable. Eat, and I'm invoking eat. And if I run that, I get nom 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 because they're eating. So again, this is called an instance method, and you can call them, /invoke them on each individual instance of the class. So Tressa is an instance of a person, so I can call or invoke them on each individual instance of the class, which I'm doing right here down here. I'm doing Tressa.eat. All right, so let's talk about if I wanted to increase the age of this person instance. I can create a method called def increase age. And again, this is going to be an instance method. And I'm going to pass in another argument or parameter called like increase years or something, years increased. And this method I can increase the age of this person any number of years I want to. And I can access the age instance variable because the self dot, whatever variable, instance variables I have access to throughout this entire class. I don't have to pass in self dot age here. I don't have to pass in an age there to get the age. I automatically have access to the self dot age on this entire instance of this person class. So I can say self dot age equals self dot age plus years increased. So I'm reassigning the value of the self dot age to whatever the original age is plus the number of years I'm determining to whatever I want, whatever amount I want to increase the age by. So, and I can return, I'm just gonna return F string. My new age is self.age. And this F string, this is how we do string interpolation, which is how do we inject variables or functions into a string. So I do F followed by string, and I can pass in variables in there. So if I wanted to increase, let's see, I'm going to just say, I'm going to create another method called or I guess just print my age. That's an instance variable or instance method. And it just returns my age is self.age. So for Tressa, I'm going to do print my age. I'm going to run that. So right here, I'm eating. Then my age is 20. So I'm printing my age. But maybe I want to increase my age. Increase age by 2 years. So I'm going to clear the terminal. I'm going to run this file again. It's going to run this eat instance method. So it's going to print num num num, and then it's going to print my age right here. It's going to run this method, and then I'm increasing my age by passing in 2 for the number of years I want to increase my age by. Pass in 2 years, and so self.age, which was originally set to 20. Its new value is 20 plus 2. So self.age will now be 22, and it should say my new age is 22. There we go. All right. Same thing with like change occupation. I can change my occupation. Say I get a new job, new occupation. I can just do self.occupation equals new occupation. I don't necessarily need to return anything because I can always just do Tressa dot change occupation. I would say like principal software engineer. Maybe you got promoted. Then in here, I can also just print occupation just to see what that looks like. So again, I'm just printing eat, printing my age, increasing my age, changing my occupation from software engineer to principal software engineer, and then I'm just printing that attribute, the occupation attribute or occupation instance variable. So now I'm a principal software engineer, or Tressa is a principal software engineer. All right. What questions do you have about these instance methods and instance variables and this Dunder and knit method? instance. Nobody has any questions? I know.
I'm curious about the use case. Like I kind of understand the format now and, kind of how to set one of these up, but like a real life application, how would this be used?
So like if you had like a bunch of users in a database and each user might have, like name, ID, username, email, etc. So you'd have a bunch of instances of users that you can store in like an array. So you can have a bunch of user instances, or just like we have Tressa here, you can have multiple user instances like stored in an array. So you can have like, so for example, if we actually had like, if we wanted to create an application for some software for like a company, like some company, like, Venmo, Google, or whatever, you're the company you currently work for. If you're currently have a job, you can have a company class that has a company name, and you can have also an employee class, and that employee class or user class, you can grab a bunch of users from a database and store those users in a user class. And then, so you have access to all those users with all their information, like name, age, occupation, etc., stored while the server is running. So you'll have access to all those users and the attributes of those users.
So would this be considered back-end code?
Yes. Right, like for what we're going to be using for yes, but you can still use classes in the front end, but you won't see. That's just long story short, you won't really use it. But yeah, this is all back end server side code. Yeah. Yep, go ahead.
So it looks like you can't change instance variables once the new instances have been invoked. So you have to use these methods to access instance variables.
So sorry, say that again. You have to use these.
I guess the simple question would be, instead of setting up these methods, why can't we change the instance variables directly?
Like just go like,
yeah, Tressa.occupation equal, yep,
equals whatever.
Right.
So if I did that, so like right now it's saying I can't do that. Let's see if it actually works. I think you can do that. Yes. So yeah, you can do what I'm doing right now, and it'll still. So if I did like print Tressa dot occupation, that does work. But typically, I mean, best practices, you don't want to change things directly in your software. So you always will want like a method to do something. So just best practice, you always want to use a method to access and change values of instance variables.
Does Python handle like similar to Java with like public and private, so that you could actually make it so it's impossible to change those variables without using setters and getters? Or is it doable no matter what, even though, like, even if you don't want people directly changing one of those variables outside of using your setter? Is there a way to prevent that or no?
Not that I know of.
Okay,
Yeah.
thanks.
Yeah, that's a good question. Yeah, not that I know of.
Is it common practice to have an instance method for each instance variable so that you can change it if necessary, or does it depend on the variable?
It just depends on the variable. So I'm just like kind of showing you examples of different instance methods, why you might use them. But you don't necessarily have to change any instance variables if you don't want to. Sorry, did I answer your question?
Yeah, thank you.
Okay.
I was just wondering if it was normal to plan a method if you create that variable, or if it's just dependent on what you're doing.
Yep. So again, instance methods, or I'm sorry, there's three types of variables in classes, generally speaking. So there's local variables. So like if I hear, I'm trying to think of like a local variable would be like increase age. If I just had like, I don't even know what I would put here. Some variable equals like 10 for whatever reason. Some variable, some var is a local variable, and it's only accessible within the scope of increase age method. So again, some variable is a local variable to the increase age method. So I don't have access to this some variable. I guess I'll just say like random num. I could create a random number. I'm just gonna whatever. So like this random num is only accessible within the scope of the increase age method. So this is just a local variable. We're not doing anything with it. I just want to kind of show you local variables. The instance variables, which has the self dot in front of it, self dot name, self dot age, self dot occupation. That is an instance variable. I have access to these variables throughout the entire class without having to pass it into any methods. So I just automatically have access to self dot occupation just by calling self dot occupation. Now there's other variables called class variables. So a class variable is the same across all instances of the class. So up here in class, so I can say like num of eyes equals 2. So every person will have number of eyes. Well, just say 2. So number of eyes, it's not defined within a instance method. It's defined outside of any method, typically right underneath the class when you're when you're defining the class. So this is a class variable. And again, this does not change, or I'm sorry, this value is the same across all instances of the object, the person class. So in here, William, person, what do you want to do after you graduate? Or William, are you currently working, or what's your dream job?
Hopefully software developer.
All right, software. All right. So we have William and Tressa. So if I do print person, so I'm calling the class now, person dot number of eyes, clear, I get 2. Let's see. So if I do William number of eyes, let's see if I get 2. If I do Tressa number of eyes, 2. Now, in order to change this value, which you rarely ever want to do, if I do change this value, it will change it across all instances of the person class. So just for what the hell, just for shits and giggles, I'm going to say change num of eyes. And I'm going to do person dot num of eyes equals 3. So I'm calling the person class, grabbing the class variable number of eyes, and I'm setting that value to 3. So if I run that, so I still get 2 eyes for William, 2 eyes for Tressa. But what if Tressa calls change number of eyes? Whoop. And then, so Tressa calls the change number of eyes variable, but now I'm going to see how many eyes William has, even though Tressa is the one who called this function. So if I run that, so now you can see initially the number of eyes for William is 2, number of eyes for Tressa is 2. Then Tressa changes the number of eyes, which comes up here in line 25, which changes the class variable from 2 to 3. And now on 37, I'm printing William, the number of eyes, and that value is 3. I can do the same thing for Tressa. See how many eyes she has now. They have 3 eyes. So this class variable changes across all instances of the class. So if I change this value, it will change across all instances of a person. So now all people have 3 eyes now. You rarely use class variables, but they do exist and you can use them if whatever attribute you want to change across all instances. What questions do you have about class variables?
So maybe this is a silly example, but let's say you have the person class and you're assuming that every time you create a new person object, with the class variable, you want everybody to have 2 eyes, right?
Yep.
But then you get a new person that you need to create and he's a pirate. So now you need to change for 1 eye. So how would you go about making sure he's got his 1 eye and everybody else is good?
Yep. So you can do that. So I'm going to say def like make pirate self. If that's the case, you would make another variable, but make a number of eyes as a instance variable. So I can say self dot num of eyes equals 1. So if I created another pirate person, Jack Sparrow. I don't know how old Jack Sparrow is. So pirate. Oh, are you saying like if I instantiated this person with a make pirate, or I'm sorry, if I created this person and they are, when I create the person, they already only have 1 eye? Is that what your question is?
Kind of, yeah. So we already know that the person we're going to create has 1 eye.
Okay.
But obviously our class is already built out for everybody that's got 2 eyes.
So if that's the case, I would probably have a make pirate flag. Like, all right, do I want to make this person a pirate? And inside my initial initializer in Dunder init, I could self dot. Oh, hold on a second. I'll make this as an is pirate. So inside the Dunder init, you can do, again, this is just like a normal method. I'd say you can do pretty much whatever you want in here. You can do like if statements, for loops, and everything in here, just like you would any other method. So here, in that case, I'd probably added a flag to make whether or not to make this person a pirate, and I'll have that flag initially as false. And if when I do create this person instance or this pirate instance, I'd make this flag as true. When it Dunder inits, it says, hey, if this is true, then run this function self.makePirate, which would change the number of eyes. So if here, make that true. And down here, I can do print pirate number of eyes. If I clear that, there we go. So number of eyes initially is 1 or 2, 2. Then trust to change the number of eyes from 2 to 3. So 2, 2. Trust to change the number of eyes to 3. And then I created a pirate that has only 1 eye. That's probably what I would do in that case.
Thanks.
But typically, you're not born as a pirate. So they would probably pirate make pirate. So I'd invoke that make pirate. So right here. So I got an error pirate line 37. This is where the error is. Type error Dunder init takes 4 positional arguments, but 5 were given. So 0, 1, 2, 3. I don't know why it says 5. But I don't need that true here anymore. Clear the terminal and run that.
It includes self when it counts that, I think, right? When it's talking
Yeah.
about the number of arguments.
Yeah, so I have 1, 2, 3, 4, 5. Okay. Yep, that's right.
Could you still run this class if you maybe didn't know a piece of information? Like let's say you didn't know the age. Could you just leave that essentially open even though you don't have it? Or do you have to have all that information to be able to run that class?
So the way it's set up now, I would need to have an age. I would need to put something in there for the age.
So could you set it as like a default? Like if you don't, like, let's say, you're going to be taking in a bunch of data that, you might not have every piece of, you could set it as a default of equals whatever.
Yep. So like right here, but I would still, if I want to add defaults, because then the order does matter. I'd put the age down here at the end. Because if I don't know the age, I probably wouldn't add the age in here. So if I like remove that.
So when you're making a class, you want to be confident that you're going to be able to get that data if you're making an instance variable for it?
Yes, for the most part, but we'll talk about ways we don't need to add all these arguments in here, where we can just have like an object or like person info, which is an object. So we're passing in an object in here, and then we can access the name, age, and if it exists, type of thing. But we'll talk about that later. But yeah, so there are ways you don't need to pass in everything in here, but you just have to architect your person class in a manner that allows for that. And if you want to check out args and quargs, key WARGS, they're called keyword arguments. There's ways to do it. Cool. All right. Any other questions so far? Nothing. All right. So I'm gonna